A new computer module that integrates artificial intelligence with satellite data of NASA could potentially sound the alarm for dangerous space weather, making the predictions for harmful events such as solar storms very easy. Currently, exact predictions about the timing of solar storms are not up to the mark. As we approach the next solar maximum, that is a peak in the sun's 11-year activity cycle, which is predicted to occur somewhere in 2025, the probability of geomagnetic storms and their disastrous impacts on our society is rising. Scientists have used this information to create the Dagger computer model, also known as Deep Learning Geomagnetic Perturbation, which can forecast geomagnetic disturbances 30 minutes in advance globally. The model involves artificial intelligence to examine data from spacecraft observations of the solar wind or the continuous stream of material from the sun and forecast the location of an impending solar storm anywhere on Earth with a 30-minute lead time. This might give people just enough time to prepare for major solar storms and avoid serious damage to power systems and other critical infrastructures. Two geomagnetic storms that occurred in August 2011 and March 2015 were used by the Dagger team to evaluate the model's potential. In each case, Dagger was able to quickly and accurately forecast the storm's global implications. With models like Dagger, it is possible that solar storm sirens will one day sound an alarm at power plants and satellite control centers all over the world, just like tornado sirens do in towns and cities across America. Just as the sun keeps sending us light and heat, it also throws out a lot of other material in all directions, including towards Earth. There is a constant stream of charged particles, electrons and protons that escape from the sun's atmosphere and spreads across space. These streams are called solar wind or solar storms. We are protected from the solar wind by our magnetic field, which deflects the particles away. Solar storms regularly occur during the sun's solar cycle. The solar cycle is the cycle that the sun's magnetic field goes through approximately every 11 years. Every 11 years or so, the sun's magnetic field completely flips. This means that the sun's north and south poles switch places. Then it takes about another 11 years for the sun's north and south poles to flip back again. The beginning of a solar cycle is a solar minimum, or when the sun has the least sunspots. Over time, solar activity and the number of sunspots increases. The middle of the solar cycle is the solar maximum, or when the sun has the most sunspots. As the cycle ends, it fades back to the solar minimum and then a completely new cycle begins.